Welcome back to Algebra 1, Topic 28, Division Properties of Exponents. This is part 3. So in this part, we are actually going to look into two different properties. So this may be a little bit of a longer video. So just bear with me and pause where you need to. So first thing is the zero exponent. So for any non-zero, key part that we learned here already, non-zero. Number A to the 0 equals 1. Now we talked about this a little bit more in depth in topics 26 videos. So if you would like to see that specific case where it is 0, you can refer back to that video. But assuming that A is non-zero, A to the 0th power, automatically 1. So if you see something and it looks like a whole lot of mess in there, and then everything is just raised to the 0 power in the end, forget about it. It's just 1. So 15 to the 0 equals 1. B divided by C to the 0, we don't know what B is. We don't know what C is. Assuming that that value is not 0 itself, it's equaling 1. Bada bing, bada boom. Okay? Now transitioning on to negative exponents. Again, for any non-zero number A and any integer n, if we have A to the negative n power, that's the same thing. If we see that negative exponent right there, that's the same thing as 1 over A to the positive n. So we are flipping it and it becomes positive. Now this goes two ways. If we have a negative exponent in our denominator, in order to make it positive, we can flip it to the numerator and it becomes positive. So basically, whenever you see a negative exponent, if it's in the numerator, flip it to the denominator. If it's in the denominator, flip it to the numerator. And when I say flip it, I mean flip that entire quantity that it's attached to. So if you have a bunch of different variables and they're all in parentheses to the negative exponent, you're going to flip all of it. However, if you just have one variable, you're just flipping that variable. Again, just flipping that variable. Okay, we're ready for some examples? Now this section's a little bit longer because it kind of incorporates both of these two properties that we just learned. So, again, pause where you need to. We're going to incorporate both of them. Let's go right across to number 1. 2 squared divided by 2 to the negative 3rd power. So here, whenever we see a negative exponent, we see it right here. We're going to take this and flip it to the numerator right away. So if we rewrite this, we get 2 squared times 2 to the positive 3 now. And we know when we have, I'm sorry, this is all over 1. We know when we have two values and they have the same base, so we have 2 and 2 here, what can we do with our exponents if we are multiplying them? We can add them. So our new answer is going to be, we have a 2 plus 3, 2 to the 5th. There you go. Okay, number 2, m divided by m to the negative 4th. Now we know this is already m to the 1st power. They're trying to trick us here. How dare they? But we see an m to the negative 4th in the denominator. We can move that. So we're going to take this whole value, flip it up. It's going to become positive. So our new answer will be m to the 1st power times m to the positive 4 power all over 1. So since we bring up that m to the negative 4th, we bring it up to the numerator to become positive, we just have a 1 in the denominator since it doesn't list any other variables or any other terms. Again, they have the same base and we're multiplying them, so we get m to the 1 plus 4, or m to the 5th. Okay, next problem. This is number 5. So again, in this foldable, it goes across from left to right instead of just this individual flap. So make sure you're looking at problem number 5 here. Negative x to the negative first, all raised to the 0 power, over 4 to the negative first y squared. Now remember what I said before? This whole thing, it looks kind of messy here. Ugly. But it's raised to the 0th power. So automatically, our numerator is just going to change to 1. Now our denominator, let's focus on that. So I'm going to rewrite that first. W to the negative first, y squared. Now, if we keep our 1 in the numerator, we have a negative exponent here, and that's w to the negative first. Now notice how it's just talking about w right here. So that's the only variable that we're going to move. So we're going to get 1 times w to the positive first power over 4y squared. So our w moves from the bottom to the top. Started from the bottom, now we're here. So if we were to simplify it, we would just get w over 4y squared. There you go. Okay, if we talk about number 6 right here. Okay, this has a lot going on. Let's focus with our negative exponents first. So if we have our negative exponent, notice how it's this entire quantity that is raised to that negative 2. That means instead of just one variable, we're going to take all of them and move them up. So if we were to rewrite this, we would get a squared b cubed to the 2nd power times ab to the 2nd power. Now we can apply our knowledge using the power raised to a power, or this is a product to a power. So we can apply this 2 to our a squared, to our b cubed. We can apply this 2 to our a and to our b. So if we want to rewrite this, we get a squared squared b cubed squared times a squared b squared. So again, we got a few more things to do here. A power raised to a power, so we get a to the 4th from 2 times 2, times b to the 6th, which is from 3 times 2, times a squared b squared. Now notice here, we have a to the 4th and a squared. So these have the same bases. That means we can add our exponents. So this gives us a to the 4 plus 2, or a to the 6th. And we can do the exact same thing with our b term here. Ooh, pretty pink. B to the 6th times b to the 2nd gives us b to the 6 plus 2, or b to the 8th. And that is our answer for that problem. Okay, few more problems for this one. 9r, I'm sorry, I reread the wrong thing. Where was I looking? Problem 9, there we go. 3rt squared, u to the negative 4th, divided by r to the negative 1st, times t squared u to the 7th. Whew, okay, we got a lot. Let's deal with our negative exponents first. So we have our r to the negative 1st. Now it's just r that we're dealing with here, so this is what we're going to move up. And we have u to the negative 4th. It's just our u here, so that's what we're going to bring down. So if we want to rewrite this, we have 3rt squared, quantity squared, times r to the 1st over t squared u to the 7th times u to the 4th. Okay. Everyone see how I've gotten there so far? So I've moved my r up because that's a negative exponent, and I've moved my u down because that was a negative 4 exponent there. So we want to get rid of the exponents So we move it to the alternate part of our fraction. Okay, now we can apply our power raised to a power. Product of powers. So we're going to apply this squared to our 3, to our r, and to our t. So we're going to end up getting 3 squared, r squared, t squared times r to the first over t squared u to the 7th times u to the 4th. Now we can combine our like terms. So 3 squared is going to give us 3 times 3, or 9. R squared, t squared times r to the first. So here we have same bases as r and r. So if we have the same base and we're multiplying them, we can add our exponents. So r to the 2 plus 1, r cubed, and then just bring down that t squared there. Divided by, here we have t squared, u to the 7th, u to the 4th. So we have u to the 7th and u to the 4th. Since they have the same base there, we can have our t squared. 7 plus 4 is u to the 11th. And then we think we're done, and they're like, nah. So what do we notice here? Again, this one's a doozy. We notice that we have a t squared in our numerator and our denominator. So actually, if we want to reduce this even further, which we should, we would get 9r cubed over u to the 11th power. And there we go. Last but not least, we have problem 10 here. So this is m to the negative third, t to the negative third, over m squared, t to the third, all raised to the negative 1. Woo! Okay, let's deal with this step by step. So we have our m to the negative third. In order to change that, we're going to bring that to the denominator. We have t to the negative third. In order to change that, we're going to bring that to the denominator. So let's just rewrite that right now. So we're going to get 1 over m to the third, t to the positive third, over m squared t to the positive third to the negative 1. Now we have this entire quantity. Whoa, what did I do? We have this entire quantity here that is all raised to the negative first. So since this is all raised to the negative first, we're going to bring this to the numerator in order to make it positive. Again, we don't want to deal with negative exponents here. They're yucky. So if we want to rewrite this, we get m squared t cubed. This is all raised to the positive first power over m cubed t cubed. Okay, now if we were to distribute this 1, it would not do anything. So what we can do is we can reduce further. We see a t cubed and a t cubed in the numerator and the denominator, so that just reduces to 1. And we're just going to be left with m squared over m cubed. Now, if we want to subtract this, 2 minus 3 is m to the negative first power. Now, in order to rewrite this, we can write this by bringing this value to the denominator, because this is really over 1. And we would get 1 over m. Now remember what I told you guys before? I believe it was part 1 of this video. Or another video, I should say. When we subtract, look where your bigger exponent is going to be. So if I have 2m squared over m cubed, my 3 is in the denominator. So that is where my positive exponent should be located. That's where my m to the first is going to be located there. Okay, and thank you for watching. That will be part 3 of this video.